Welcome to the second practice problem in the Programming in Python 3 course. Just like the first problem, I have two parts prepared for you today, and the topics that these are going to really be going over are if statements, math, user input, and typecasting. If you're new to these practice problems, the main thing is that these are completely optional, and if you don't want to do them, you don't have to do them. In the first half of the video, I'm going to read through these problems and talk about them a little bit, and then in the second half, I will be giving you my solution to what these problems are. I haven't prepared any solutions to this, so it'll be authentic, and you'll really get a full experience of what my process is for programming, and hopefully gain your own practices for when you implement these problems. The biggest thing is I highly encourage you try these problems on your own before watching my solution, just so that you can start to really use your problem solving skills to try and find a good solution to these problems. So let's go ahead and get into these. So the problem for part A says that given a year from the user, determine whether or not the year is a leap year. And in order for a year to be a leap year, it must have these requirements. So it must be divisible by 4. If it is a century year, so in other words, if it's divisible by 100, they're not leap years unless they are also divisible by 400. And a few examples of what a leap year is 1600, 2000, and 2020. And then a few examples of years that aren't leap years are 1700, 1800, and 1900. If you want to go ahead and give an attempt to a little bit of a harder problem, the bonus problem for part A says ask the user for a future year, so a year that is in the future of the current year, and determine whether or not that is a leap year. If it is, tell the user how many years away it is, and if it's not, then don't do anything else. So let's go ahead and get into part B. So rock, paper, scissors is a very simple game that just about everybody knows. I'm sure you know it. But if not, and you're unfamiliar with the rules, essentially you're going to pick either rock, paper, or scissors, and the opponent will pick also rock, paper, or scissors. And then there are specific rules for who wins. So, for example, rock always beats scissors, paper always beats rock, and scissors always beats paper. So for this problem, we're going to make an implementation of this in Python. I have provided the code to allow the computer to make a choice of either rock, paper, scissors. It's completely random. You don't have to understand this code because we will be going over modules and the necessary stuff to really understand this code later on in the series. But for now, just take it and put it in the top of your file, and then that'll handle the computer making a choice for rock, paper, scissors. You also might notice that I have the computer choosing either 1, 2, or 3, and that is because, as a hint, I thought it might be easier for the user to input a number rather than a string. So instead of saying rock, paper, scissors, that could have a lot more room for error. So maybe it'd be easier to do either 1, 2, or 3 and maybe have some sort of menu system, and then maybe have 1 stand for rock, 2 stand for paper, or 3 stand for scissors. That's how I would do this, but obviously you can do whatever you want. But just keep in mind that for the computer's choice, it will be choosing from 1, 2, or 3. So if you don't want to do these numbers, then go ahead and change this 1 to rock, and then 2 to paper, and 3 to scissors as the form of a string. So this is going to be my solution for part A. Just something to keep in mind before I get into it is essentially, it's just important to know that if my solution or my code looks different than yours, it doesn't mean that yours is wrong. As long as your outcome is pretty much the same, or whether or not your outcome really determines if a year is a leap year or not, that's all that matters. People are always going to have different solutions to different problems because they're going to think differently, and that's just something that you should know when going into either this career or if you just program for fun. But anyways, let's go ahead and take a look at what part A says to do. So this is going to be the normal problem, not the bonus problem, but I will have the bonus problem later on after I solve the original problem. So it says to give a year, or get a year from the user, and then determine whether or not it's a leap year. So the first part that I can really have from that is essentially just get input from the user. So I'll have a variable called year, and I will cast that to an integer from the input and say enter the current year. I'm going to have it be the current year because we don't need to have any other year for this problem here. But what we can do is have that, and then now we need to really determine whether or not it is a leap year. So first of all, it has to be divisible by 4. If it's not divisible by 4, then it is just flat out not a leap year. So we're going to say determine whether it is a leap year. So I'm just going to keep this note here so we know. And the first thing is if year mod 4, if I could find it, there we go, is equal to 0. So that means if it is evenly divisible by 4, then I'm going to use this pass keyword for now just to kind of fill out the if statement. And then the else will handle whether or not it's not a leap year. So I'm going to put in here, I'm going to print a message out saying, I'll say year is not a leap year. And then we'll just have that. And I'm just going to separate it by a comma to put a space in there to really save a lot of time and effort. So now let's go ahead and really do some of the work to figure out whether or not it's a leap year. So if it's divisible by 4, that's really not enough for us. We need to determine whether or not it is divisible by 100 as well. So if it's already divisible by 4, I think for readability purposes and just for ease, I'm going to have another if statement in here that says if year is divisible by 100, and then I will, once again, I will put in here like pass for the time being, and then if it's not divisible by 100, then you just want to, it's actually going to be a leap year, right? So we'll have year is a leap year. So that will handle like the first case really. Well, the first case is it divisible by 4? If it is, then do all this stuff, but if it's not divisible by 100, so if it's not a century, and I'm going to say like is a century, and then else is just not a century, and then in that case, if it's divisible by 4, it is a leap year. So like 2020, for example, is not on the century, but it is a leap year because it's divisible by 4. And then it says that if it is divisible by 100, it also has to be divisible by 400. So inside of this, if we have another if statement, so I'm nesting like 3 if statements in here, and I'm going to put if it's divisible by 400 and it has to equal 0 because that means it fits in there evenly, then this is going to be, once again, I'm just going to copy and paste this code. No sense in retyping it if we already have it here. And then if it's not divisible by 400, then that means that it is not a leap year, right? So let's go ahead and see if this is right. So I have a few like examples here. So leap year 1600, 2000, and 2020. So let's go ahead and run our code. And the current year, or I guess it shouldn't be the current year, it should really be just any year. So enter a year, right? Not the current year. So let's do that again. So enter a year, we'll do 2000. 2000 is a leap year. Awesome. So let's go ahead and just make sure, so that's on not a century. Now let's go ahead and try one of our examples of years that aren't. So 1700, 1800, and 1900. So we'll run this again. And 1700, it is not a leap year. And once more, 1800 is not a leap year. Awesome. So this was a pretty straightforward implementation. I think the main worry with problems like this is just understanding the logic of where to place your if statements at. Obviously, you could have made this a little more complicated with a lot more ands in here. So for example, technically it's only a leap year if it's divisible by 4, but inside of here it has to be like if it's divisible by 100 and divisible by 400, and then if it's not, then it's, you know, not a leap year, but everything else is. I see this as the most straightforward implementation, but if you came up with a more expanded version of this, or maybe a more shortened version if possible, but you got the same result, then I would say good for you. That is perfectly fine. So now for the bonus problem, it says to ask them for a year in the future and determine whether or not it is a leap year. So I'm going to just set this as like the bonus problem here, and then I'm going to give myself a good start and copy all of this and then comment this out. So now I'm going to change this to like current year, and then I will, you know, have like, or not current year, but we'll have current year and then future year. And then I'm going to copy and paste this line, and I'm going to say enter a year in the future, and then enter the current year. So I'd say, since I specifically mentioned a current year, I may not have explicitly said this in the problem document, but I think what I'm going to do is just make sure that this future year is actually in the future. And then the way we can do that is really just if the future year is greater than the current year, then we'll do all this stuff. And then if it's not, then we will just say, like, you know, not that that year is not in the future. So else print the year provided is not in the future, and then it won't do anything. So now we need to take the future year and print, see if the future year is, you know, a leap year. And then if it is a leap year, we want to basically say, like, it is a leap year and then how many years away it is. So we can actually do that by, like, just, you know, simply subtracting the years. So we can do, for example, I'll just create a variable here. I'll do like, I'll call it like years between, and then I'll take the, and ideally if the future year is bigger than the current year, then that's the one that you're going to want. And then I'm going to move this down into the if statement, because if it's not bigger, then you're actually going to have an issue and the year is going to be negative. So you don't want to calculate that beforehand. So now we have that in here. And then let's go ahead and just print how many years away it is. So if it is a leap year, we want to do it. So we'll do print, we will do future, or actually we'll put this in the same. So we'll do future year is a leap year, and it is, and then we'll do like what I put, years between, years away. And then we can just copy that for everywhere else that it is a leap year. And then that should handle it. So, for example, 2024 is a leap year. So, I can do, if I run this now, it'll say enter the current year. I'll put 2021. And then enter a year in the future, 2024. So it says 2024 is a leap year and it is 3 years away. Now let's try and run that again, but maybe let's try putting in like 1999. And then we'll do a year in the future. Oh, yeah, 1998. Say the year provided is not in the future. So obviously you could have hard-coded the current year in if that's something you wanted to do. The reason I didn't is, let's just say for some odd reason that this program is executed in 2025 or, you know, 2030 or whatever, if Python 3 is still around and popular, then it'll really be able to just be dynamic to whoever is running the program. But you could hard code it in and the result would not change. So this is going to be my solution to part B, the problem where we implement rock, paper, and scissors in Python. There is a bonus problem, but it's really not like a major, you know, like a huge bonus problem. We'll get into that after we just make the base game of rock, paper, scissors. So, like I mentioned, I have code that I gave you to give the computer a choice. Let's just make sure we tab this in here. All this line really does is, so this top line imports the random module. Well, we'll get into modules later on in the series. So don't really worry about what this does. It just essentially allows us to have functions from like an external place or the Python standard libraries where this is coming from. And then this random.choice is a function we're calling. So the choice is a function from this random module. And then it's going to allow us to pick items from a list. So for the hint, I said that it might be easier to have the user like input a number and then that will stand for rock, paper, or scissors. That's how I'm going to implement this, and that's how I have this computer choice here. But if you chose something different and you could change those 1, 2s, and 3s, or that 1, 2, and 3 to like a string value, and then just check it on that, that's totally fine. But like I said, it's just easier to deal with numbers in my opinion. So let's go ahead and get started. So this is the computer's choice. Now we need the player's choice. So essentially I'm going to I'm going to create like a little menu, if I could type, system here, and then I'm actually going to have a few prints. So I'll have like 1, and then I will copy this and have 2 and 3, and this will be rock, paper, scissors, and then I'll have one more print at the top that says to like make a choice, and then these will be your 3 choices, and then the input function will just be like a little prompt thing. So this will be the player's choice here. So maybe like let the player choose. So this handles the player's input of either rock, paper, and scissors. Now it's time to handle the logic of essentially who wins the game. So we're going to want to know if the player wins or if the computer wins. So the rules, like I mentioned, are if the player has rock, that beats scissors. So what I can do is mainly have an if statement. So I could say like if player choice is equal to 1. So this will be if the player has rock. And the only way that the player could win is if the player choice is 1. So we'll do like if the player choice is 1, and then we'll nest an if statement and say if the computer choice is equal to, so we'll do the tie first. So we'll do if computer choice is equal to 1 and the player choice is equal to 1, we'll print there's a tie. And maybe I'll also print like, oh yeah, we'll do there's a tie. So now you know, that's, or we'll say like you both chose rock, there's a tie. So that's the tie cut out of the way. Let's go ahead and implement if the player wins. So that's if they both got it, but now we can do an elif here for the computer choice, and essentially we can see if the computer choice is equal to 2. So that would be if they chose paper. If the player got rock and the opponent got paper, according to the rules here, paper beats rock, so that would mean that the computer won. So we'll say like you chose rock, the computer chose paper, computer wins. And yeah, just for like formatting's sake, I'll just put that there. Cool. So that's that. And then essentially if they didn't choose 1 or 2, then that would mean that the computer lost. So we'll say you chose rock, the computer chose scissors, you won. Or we'll say you win, just to make it uniform. Awesome. So that's the first condition here. Essentially we're just gonna really copy and paste this and change those to like elifs here. So this will not be an if statement, this will be an elif statement, because we don't want it to execute afterwards, because if it's an if, then it's gonna, you know, run that twice essentially. So this will be if it's 2. So we'll do the tie condition first. So if it's 2, then, or well, we'll just do it in order again. So if it's 1, 2 means that it is paper, and if they chose 1, that is rock. So that we'll say you chose, oops, can't type today, oh my gosh, there we go, chose or you chose paper, the computer chose rock, you win. And then the choice for 2 would mean that you tied. So we'll just do, you both chose paper here, and paste that in, and then we'll say you both chose paper. There's a tie. And then the final condition is if they chose scissors, and the scissors condition would actually be that you lost because scissors can cut paper. So we'll say you chose paper, the computer chose scissors, computer wins. And then finally the last condition, so if you have a 3 here, oops, I'm gonna actually copy and paste this here, and the reason why I'm doing this is actually because of the bonus problem here, but we'll get into that later when I give my my implementation of it here. Let's just make sure that the tabbing is all right, because I pasted that in, it kind of messed up with the tabbing here. Oops. So let's fix that. So that's the tabbing right, and this time this will be if you chose scissors. So I'll actually comment this too. You choose rock, or I'll just say like rock here. And then this one will be paper. And then this third one here will be scissors. So you choose scissors, so that means if you choose scissors and the computer chooses rock, you lose, because just like we went to the rules, rock beats scissors, right? So you're going to say you chose scissors, the computer chose rock, and we're going to say computer wins, right? So now if you choose 2, so that would be if you chose scissors and they chose paper, that means you would win. So we'll say you chose, let's see, what are we on? Scissors. The computer chose paper. You win. And then else, that is the tie condition, because that means you both chose, you both chose scissors. So you both chose scissors. There's a tie. Awesome. So we actually have our game logic implemented here. Let's just go ahead and give it a shot. Also, before I go into this, it's important to know random.choice here. This so the way that random works in programming languages, in Python and a lot of other languages, is that just because it is technically a random choice, throughout the span of the lifetime of the program, the choice is always going to be the same unless you rerun the script. So just something to keep in mind. But let's go ahead and run this. So make a choice. So we want to choose like, let's choose, I don't know, I'm feeling it, rock. We both chose rock, so there's a tie actually. Let's try that again. Let's do rock. And let's do it one more time. So you'll see that the first time we both tied, but now I chose rock, they chose paper, they won because paper beats rock. Let's go ahead and try that one more time. I'll do paper this time. They won again, so I'm losing. So just to make sure that our choices are really random, I have high confidence in this program, but we'll just make sure that like our logic is correct. We will print, so we'll print the player choice and then the computer choice as well, just to make sure that we're doing okay here. So we will do, let's do rock again. So it was 1 and 3. So if we go down to here, so we do 1, 3. So we won. And 1 is rock and 3 is scissors. So yeah, that checks out perfectly. So that's good. I'm not going to test it for the rest of them, but like I said, I have high confidence in this. Cool. So our base program works. Let's go ahead and get into the bonus problem. So this says throw an error message if the user does not input a valid choice, and then don't allow the game to continue. Well, The way that I actually set this up, it really makes it easier for us to do this. You can actually just add an else condition here, and this will handle if the user inputs anything that's not 1, 2, or 3, right? So I could just put like, call the print function and say that's, or I'll say like, or what did I call it? Player choice. Player choice is not a valid choice. And then we'll say like exiting game. And it's really just gonna, that'll be the last line of the code. I know for a bonus problem that wasn't too terribly difficult, but I did think that this problem here was a pretty complicated for beginners, especially when you're learning if statements. But let's go ahead and try this here. And then I'll go ahead and type in 4, and I'll say 4 is not a valid choice, exiting game. Perfect. This was practice problem 2. I hope you all enjoyed it and had a good time trying to solve the problems that I've created for you. Our next practice problem won't be until after a few more videos in the series. These videos are going to be us going over errors, strings, lists and tuples, and then looping. And after the looping video, we will have our next practice problem. Like I mentioned before, the next video in the course is going to be about understanding errors.